Okay, so this is part 2 of the ACE Calc review for the final exam. Now, in part 1, we did questions 1 through 8, so if you've not watched that video yet, please make sure to go back and watch part 1 first. Okay, so we're going to start with number 9. Number 9 is a rate of change question. So first, we're going to come up with a formula and then state our givens, and then we're going to take the derivative and then plug in our givens so we can solve. So I'm going to read this. Find the rate of change in volume of a sphere whose radius is changing at a rate of 3 centimeters per minute when radius is 8 centimeters. So we're talking about the volume of a sphere. So I need a formula for the volume of a sphere. So that is volume equals 4/3 pi r cubed. Okay, so I also am given the radius is changing at a rate of 3 centimeters per minute. So that is dr dt. The rate equals the derivative. So that's 3 centimeters per minute. Okay, so when r equals 18, so r is 18. Okay, so the next step is we want to take the derivative. So I'm going to take the derivative with respect to time. So the derivative of v is dv dt. And then over here I'm going to multiply. So 4/3 times 3 is 4 pi r squared. And I'm going to label it with a dr dt. So I have my formula. I wrote the givens. I take the derivative. Now I'm going to plug in. So I'm solving for dv dt, the rate that the volume is changing. I know the radius is 18, and I know dr dt is 3. So you can use your calculator to plug that in. Now if you have the Inspire, you're probably going to get an answer with a pi in it. So that's 3,888 pi. Now, and if you have the 84, you're probably going to get a decimal. So 12,214.512. And for both of these, we label them as centimeters cubed per minute. And either one of those will be fine for your answer. Okay, moving on to number 10. Number 10, we have a definite integral, and right away I see a radical. So first off, I'm going to rewrite this. And another thing I can do is I can combine these x's. This is, I'm going to add the exponents. 1 plus 1/2 is 3/2 dx. Okay, so the next thing we're going to do is we're going to take the integral. So when we take an integral, we add 1 to the exponent and we divide. So if I add 1 to my exponent, that gives me 5/2. So out in front, I would have a 2/5. And now we're going to evaluate from 4 to 9. So I'm going to plug in 9 first. We always do top minus bottom, 2/5, 9 to the 5/2. Minus, now we're going to plug in 4. And again, you can do that all at once on your calculator. If you have the Inspire, you're probably going to get a fraction, so 422 over 5. If you have the 84, you should get 84.4. Okay, so the next couple of questions deal with U substitution. So let's start with number 11. Now number 11, we can't separate this too easily because we'd have to first evaluate x cubed plus 5 to the 4th power and then do some distributing, and then we could take the integral. But that's a lot of work. So here's where we're going to try some U substitution. So I'm going to find the inside part, which is the x cubed plus 5. And I'm going to set that equal to u. Now I'm going to find du. Du would be 3x squared dx. And I'm going to plug it in 3, take out a 1/3. So I'm going to rewrite my problem. I've got 1/3 times the integral. What's left would be u to the 4th du. And now I'm going to find the integral. So I'm going to set this equal to 1/3. I'm going to take the integral, so I'm going to add and divide. That's 1/5 u to the 5th plus c. And if you want, you can combine these. You don't have to, but that's 1/15. And our last step is to plug back in for u. Okay. So moving on to question number 12. We have another u substitution. So I'm taking the integral. This does not look like a question we'd normally do where we just work from left to right. So I'm going to look for an inside part. So I see parentheses. I'm going to start there. So I'm going to set u equal to 1 minus 2x squared. And now I'm going to find du. Du would be negative 4x. Okay, so, whoops, I forgot my dx. So let me put that in there too before I keep going. Okay, so I need a negative 4x. I don't have that, so I'm going to add 1 in. That means I got to take out a negative 1/4. So rewriting this, I've got negative 1/4, the integral, 1 over u squared du. So if you want to pause it right there to understand that or take another look at that, go ahead. But negative 4x dx is du. Some people write the du on top. I always write it on the side, so it makes more sense to see later on what I'm taking the integral of. And then I've got u squared on the bottom. Now, one last thing before I take this integral. I'm going to rewrite it once more and write this as u to the negative 2nd. Right? We don't know how to take the integral of a fraction, so we have to write it like we normally take an integral with just an exponent. So next step, I'm going to take the integral. I'm going to add and divide. If I add 1 to negative 2, that gives me negative 1, and then divide by that. Don't forget your plus c. So I'm going to multiply these together. That's positive 1/4 u to the negative 1st plus c. And then our final step, we're going to plug back in for u. Okay, then your last two questions deal with what we've been talking about in this past unit. So areas and volumes. Again, the most important part is that you get a nice accurate graph. You find the shaded region, and then you also find your boundaries so you can set up your integral. And I will let you use your calculator to solve these. So let's start with, we're going to find the area of this region right here. So you might want to pause it and graph this on your calculator. I'm going to draw a sketch on my paper while you do that. Okay, so we've got my orange line is my parabola, x squared plus 1. My green line is my x plus 3. Next, you're going to want to find your points of intersection. So you're going to use your second trace intersect on your calculator to find these 2 points. This one is at negative 1, 2, and this one is at 2, 5. So now that we've got that, now we're ready to actually just set this up. So you're going to get most of your points on your test from the setup. So you want to be very careful. Your area is equal to the integral. So my region goes from negative 1 to 2. And it's always top minus bottom. So the top line is my green line. That's my x plus 3. Minus the bottom line is my orange line, that's x squared plus 1. Now I notice one common mistake people make is when they subtract the bottom, they forget to put it in parentheses. You're subtracting a quantity, so you want to make sure you put it in parentheses. Because technically, if you weren't using your calculator, you would distribute this negative next and then combine like terms and take your integral. So now go ahead and pause the video, use your calculator, do your Math 9, or if you're using the Inspire, you're going to go to Menu, Calculate, or Menu Calculus, and then the integral. So this should give you exactly 4.5. Okay, the last question, number 14. Determine the volume of the solid of revolution obtained by rotating the region bounded by y equals negative x squared plus 3x and the x-axis about the x-axis. So while you graph that on your calculator, I am going to draw a sketch on my paper here. If I'm going too fast, just make sure you pause it. And then when you're done, go ahead and find your boundaries. So where this red line crosses the x-axis. Okay, so we're rotating this region, my shaded region, about the x-axis, so I'm going to mark that as well. And I'm going to pick a little rectangle here. Rotating that around gives us a circle. So remember, the area of a circle is pi r squared. And the radius is just going to be the height of that circle there. Okay, so I'm going to go ahead and set up my problem. Volume is equal to pi times the integral. My boundary goes from 0 to 3. R, which is my height of that function. That's the negative x squared plus 3x squared dx. So it's still pi r squared. Okay, so now go ahead and pause it and calculate that on your calculator. Don't forget your pi out in front. And so your final answer for this one should be 25.447. Okay, so that concludes part 2 of your final exam review.